Hi, my name is David Geelan. I'm an Associate Professor in the School of Education and Professional Studies at Griffith. I'm delivering the physics modules because that's my field. Richard's delivering the chemistry modules, but he's a chemistry professor and I'm an education professor. So he's invited me to talk a little bit about the syllabus document as it is, the chemistry syllabus. My own background is in chemistry and physics. I graduated with a chemistry major and a physics minor, but then most of the schools that I taught in wanted me to teach physics, and I went back and studied some more physics as well. So probably stronger in that field than chem now. Pretty comfortable with both. And the chemistry and physics syllabuses, the 2007 Queensland syllabuses, are incredibly similar. Basically all the features are very similar to one another. There are, I believe, 5 people who are studying both chemistry and physics. And if you've already seen these lectures in the physics course, you can probably skip them in chemistry because, as I say, they are very similar indeed. And you already have the skills and tools to look into the syllabus document, use it for planning, teach in context, talk about assessment in Queensland senior chemistry education, and so on. For everybody else, hi. And hopefully this is useful. There's a short session or short set, I guess, of 4 explanation videos of various facets of the syllabus, curriculum, pedagogy and assessment in Queensland chemistry education. And I hope that those are useful to you. I'm very happy to answer questions and be involved in whatever way is most useful. This is a distinction that I've been using for ages, and it works quite well because it allows you to distinguish between 2 things that are often confused. That is, the syllabus is the document that the government hands down. The government, through the Department of Education or through an entity like the QCAA, Queensland Curriculum and Assessment Authority. Sorry, I lost it for a moment there. And there have been some changes from the QCA and other bodies being joined in and so on. Or the Australian Curriculum and Reporting Authority, Curriculum Assessment and Reporting Authority, ACARA, which creates the junior secondary syllabuses. The primary and junior secondary syllabuses. So the syllabus is in some way mandated by the government and tells teachers what they must teach. And that's true in all schools. If you're going to be a registered school in Australia, then you need to be teaching to the syllabus. So, for example, this is one that I guess that comes up less in chemistry, but if you're in a Christian school, you need to still be teaching evolution, not as something that students must believe in, but that as something that students must understand and be able to demonstrate that they understand, because it's part of the mandated syllabus, and so on. So that the syllabus determines what the requirements are for what must be taught in all schools in Australia. Or in all schools in Queensland in the case of these senior syllabuses, because we haven't moved to the national syllabus set up in Queensland for senior courses. Curriculum is a different thing from syllabus. It's the thing that's developed in the school. And the reason that I think the distinction is important is because if you assume that the syllabus is a curriculum, you're going to just try and teach straight off the syllabus, and you can't. There's not enough detail, it's not clearly enough laid out. It's a framework within which you do curriculum development as teachers, as ideally a group of teachers working together, a professional team. Of course, this terminology has been slightly broken because ACARA calls their document the Australian curriculum, whereas I would call it the Australian syllabus. So that just makes it slightly confusing, but I'll use it this way with this particular distinction between syllabus, government document, curriculum, what teachers build in schools, set of planned activities, learning activities, assessment tasks, and so on. Developing curriculum, I already said, ideally between a group of people. It's much easier and better. 2 heads are better than 1, 5 heads are better than 2, to get ideas from a group of colleagues and work together. And that doesn't mean you go off and do Unit 1 and I'll go off and do Unit 2. That's still not really collaborative. And we know it's harder to find time to do those collaborations in schools these days. But ideally, the more you can collaborate, the better it's going to be. The syllabus is the framework within which it must be built, but it's not the Bible. And we'll talk a little bit about the structure of the chemistry syllabus and why you really do need to put in some work on the structure, the order, and so on. Don't reinvent the wheel. Steal from the best. Adopt and adapt. There's a bunch of resources out there. There's no point creating everything from scratch. Learn to search, learn to find the good stuff, and then adapt it to your context and your students. You have more freedom than you think you do. We continually hear about the syllabus being overcrowded and too much to learn. But if you actually look at the detail and how much is actually there over the 220 hours that you've got to teach it in, you actually have a fair bit of freedom as long as you do it sensibly. If you find ways to combine things, if you don't think of it as this is a massive list of things that I must go through and tick off. That's kind of irrelevant, because what ends up in the students' heads in terms of both knowledge and skills is what counts. The fact that you've gone past it and ticked it off, that you've covered the curriculum, doesn't actually mean anything if the students don't learn anything. So figuring out how to actually be efficient, how to do learning in ways that make best use of the time, because you'll get more learning that way. And curriculum development obviously is an ongoing adaptive process. In other words, you build something this year, but then next year's class is different. Their interests, their abilities, a whole variety of things. You have to change it. The syllabus changes, the government changes its mind about what's important, or a whole variety of other possibilities and issues that might arise. So it's never done. It's a live dynamic document in that sense. Speaking of changes, obviously we know that there are changes forthcoming to the Queensland senior syllabuses that are scheduled at least to start in 2018 for Year 11 students, and therefore be finished for the first time in 2019 by that class. Now we know that these things sometimes get pushed back by the government as well. We should plan as though we're going to be using the new syllabus from 2018. So we'll allude to that. It will be more high definition, more detailed. You'll have less freedom to move around within the syllabus document in terms of where things are taught and how they're taught and so on. There will be a 50% external exam that is required in sciences and maths. It's 25% in humanities and arts and so on, but 50% in science and maths. But that's kind of all to come, and it's still really very early draft stage. And we've been asked to prepare you to teach under the current syllabus. I really like the current syllabus. I think it's great. I think Queensland does things that other states don't do. And I think it gives you the autonomy to do some really great teaching. It's been since 2007, so it's 9 years old. We've been left alone for a while with the one syllabus to really learn and to develop our skills, resources, etc. And that's actually a really good thing. But the new syllabus is coming, so we're kind of aware of that as well as an issue. I suggest when you're doing your curriculum planning that you do it in terms of student activities. So rather than saying, these are the pieces of content that I'm going to deliver, these are the learning activities that students are going to participate in order to develop the understanding of the context. That does a few things. One of them is it reminds you that even Year 11 and 12, they're senior secondary, but they're still very young people. They still have relatively short attention spans. So it reminds you to change up the activity on a regular basis, which keeps you interested and keeps them interested. But it also kind of makes sure that you have a variety of activities, a whole interesting things that you're actually doing, that there isn't just a pattern of turn up to class and do the exact same thing every day, and so on. So it's something that I encourage in terms of planning. In the Queensland Chemistry syllabus, and this is the same as the Queensland Physics syllabus, it's similar to the Physics-Biology syllabus, Queensland Biology syllabus, although the biologists have decided to name a few things slightly differently. Not really sure why, aside from being biologists, but there's a lot of similarities and a few differences. But chemistry and physics are very similar indeed. So a view of science and science education, a rationale, some information about teaching in context, which we'll talk about later, a content strand, content knowledge, skills, attitudes and values. These pretty much parallel the strands in the junior secondary curriculum that you're very familiar with. SU, science understanding, which is kind of the content strand. SIS, science inquiry skills, which is the process, the skills strand. And science is a human endeavor, which is kind of the attitudes and values or social context, socio-scientific reasoning, etc. strand. So this is familiar from junior secondary stuff. You know how to do this thing. In terms of assessment types, there are essays, supervised written assessments, or supervised assessments. I should have crossed out the written. Supervised assessments is what they're called in chemistry. And it's very slightly confusing because essay sounds like essay, an assignment that you write. But an essay in this context is a test, an exam, something that's supervised by the teacher, so the students demonstrating their knowledge, and we'll talk a bit more about assessment shortly. Extended response tasks are more like an assignment, where the students go to the library and do research on that and so on, and write a written report. And extended experimental investigations are one of the really cool features of this syllabus, which is a sequence in which students behave most authentically like scientists. They come up with a scientific question and they spend 4, 6, 8 weeks conducting real experiments, generating real data, analysing it and making and testing their own scientific claims. So it's a very cool thing. I hope we get to keep it in the new syllabus. I'm not sure whether we will. I'm hopeful, but it's a little bit too early to tell yet. So the actual syllabus itself isn't particularly long. It's the PDF is about 57 pages, if I can do that maths in my head. Just under 60 pages. It's easily available. Just Google Queensland Chemistry Syllabus and it comes up as a PDF in one of the first 2 or 3 results, or you probably already have a copy. It's about 42 pages of that is the syllabus itself, and then there's some resources and appendices and other bits and pieces. In physics, they used 3 organisers: forces, energy, and motion. In chemistry, they've used two organisers: structure and reactions. The organisers don't mean like, okay, you should do structure in year 11 and structure in year 12. They don't give you much sense of what you should teach when and how. They are there as overarching concepts. So, we talk about learning the big idea in science. So there are these 2 big ideas. But of course, in chemistry, everything's connected to everything else. If you draw a concept map of, you start with bonding and you end up with magnetic, sorry, brain's not working. Metallic bonding, ionic bonding, covalent bonding, van der Waals and hydrogen bonding and those forces and a whole variety of things. But then you need electronegativity, you need charge, you need structure, you can link off from that to organic and a whole variety of things. So everything kind of connects to everything else. The concept map gets big and complicated. So dividing it out into these 2, I don't think helps all that much. And the order in which you teach things is up to you. This is one of the freedoms of the current syllabus, is that you have quite a bit of latitude in terms of which order you teach things in. Now, Richard has chosen a particular order for this course that I think mirrors the order in first year university chemistry, and that is rational. He's chosen a particular approach, and he may have already talked to you about his rationale for why he's chosen that particular approach rather than other possible approaches. There are 2 issues here. There's the structure of the discipline itself, chemistry, and then there's the structure of what works for students. In their heads, what order makes sense and works well. So what gets rid of the common misconceptions before they arise and so on. So up to you to design that structure in your program of work. The depth of treatment guide, page 50 to 56, so this is in the appendices of the syllabus, I find in some ways more useful than the bit on the content earlier in the syllabus, because it then talks in some considerable detail about this is exactly what they need to learn. But because the organisers are not kind of discrete things anyway, there's some repetition in the guide as well. But it's a nice place to start in getting a sense of, well, what do these students need to actually know by the end of these 2 years? What do the knowledge, skills, attitudes do they need to have? In terms of the overall structure of the syllabus, they need to do 220 hours content across the 2 years. So very roughly 110 hours a year, 55 a semester. But of course, they do actually finish relatively early in year 12. So you probably need to do more of that in year 11 than in year 12. But they need to have that much contact. So that's something that hopefully your school timetablers are taking into account, and also giving you a bit of extra latitude because sports days and public holidays and events run into and you lose some hours. Excuse me. Talked already about no particular order of topics. You get to decide that. at least one unit taught in context is required in each of year 11 and 12. And we'll talk a little bit later about teaching in context in some detail. One EEI is required at least in year 11 and one in year 12. And we reduce the scaffolding between the year 11 one and the year 12 one. And I would encourage you, this is something I've been saying for the 20 years that I've been a teacher educator. Learning science isn't learning to memorize and regurgitate stuff. Learning science is learning to understand the world. So our scientific theories help us to explain what's going on in the world around us. And that's what they're for. So we want the students to see these things in the world around them. So see the experiment, see the color of the solution change, or the temperature change, or the solid dissolve, or the material sublime up the sides of the test tube, or a whole variety of things that happen. And then the theories are used for explaining those things that happen, rather than the theories just being something to memorize for the test, right? So this empirical ground, this support in evidence and experiment for the knowledge that they're learning is really important, because it helps them to actually make it real for themselves and then use it to explain other things and other experiences in their life. My students report to me that they can do this relatively easily, that some of them use up to 33%, a third of the time, doing various practicals, demonstrations, other things like that. It really does transform a science course, and incidentally, it makes students enjoy it more as well. But you don't do it because it's popular, you do it because it's actually better science teaching. Mentioned that the syllabuses are going to change for the next couple of years, and I think I've really said everything that's on this slide. The only other piece is that assessment task, rather than currently, and we'll talk about this when we talk about assessment more, currently the assessments are done in the schools and then monitored at a panel at the end of year 11 and verified at the end of year 12 by a panel of peers across multiple schools, which again is quite a nice system, and it's a way of making sure that in a system which is all internal assessment in schools, that a high achievement in the Gold Coast is the same as a high achievement in Mount Isa, is the same as a high achievement anywhere in the state. So that process, it can be quite laborious, but it's also a fantastic professional development, professional learning opportunity to learn how other people are doing assessment and making these judgments. That's the current system, which you'll be working in for the next couple of years. The new system will be that you create an assessment task, send it off or upload it. Somebody else, somewhere else, who's got panel training, moderates that assessment task and says, yes, this is an appropriate level, or no, this is not an appropriate level. And then once you've got approval for it, then you can administer it to your students. So clearly no creating the test on the night before or the weekend before the test, because it's going to be some considerable turnaround time for this process. So you'll create your assessment tasks, send them off to somewhere, and they'll be pre-approved. And then given that the assessment task has been pre-approved, then the results obviously will be accepted. So this is quite a big dramatic change, and obviously more news to be coming on how that's going to work. But that's the short version, intro to the syllabus and some of the issues around the syllabus, and we'll talk further about a variety of these bits and pieces as we go along.